Okay. So we want to hear, we want the answer for number 7, which was a ready for more. These questions are a little bit of an extension if you think about that, right? And so this is from 1.4, right? So for this question, it's asking if the rabbit pen does not have to be a rectangle, hint, hint, it doesn't have to be a rectangle. Is there a way to get more area with 72 feet of fencing around the perimeter? And the answer is yes, but now I'm scrolling through the answers and I don't see a different shape, right? So is there a way of getting it bigger? And so if you noticed when we were doing this earlier, we had a 1 by 35, right? We had a 10 by 26, and then we had an 18 by 18. 18 by 18, you guys told me from an earlier slide, that's the biggest possible area if it's a rectangle. Now here it says if it doesn't have to be a rectangle, now what? So the answer to this, it has to do with a shape. Now, what shape could it be besides a rectangle? What shape could it be besides a rectangle? And so our answer, I'm sorry, I'm scrolling up now. So our answer for this one is pretty interesting. Does anybody know the answer for this? Anybody want to take a guess? Sorry, I'm trying to find the right page. Here you go. No, not a trapezoid. The square is actually an 18 by 18. It's not going to be a quadrilateral. In fact, it's not going to have any edges or corners. Yeah, Giselle, good job. Yes, Giselle said it's going to be a circle, Miss Johnson. It's a circle. Okay, so I know this answer is a circle because I took math classes that passed this math class. So the reason why I know it's a circle is because it's like, if you think about, okay, so let me back up. If you think about what a square is, let me draw a square really quick. When I draw, oh, it's not gonna let me. When I draw a square, right? When I look at this square, right? This is a square, right? And if this is 18 by 18, notice here, it's like you lose some area in this like corner, right? You lose some of this area versus if you had the same amount of fencing, except for now, I'm gonna make it a circle. Do you see? You can't tell if this is the same amount of area, but do you see how I'm capturing more area with a circle? If I undid this square and I laid it all the way around this circle, do you see how the circle is actually going to give you the maximum area? And this is something that you will learn in calculus in 12th grade when you learn how to do these things. But I like how you guys were all thinking, okay, when you answered the 324 square feet for 18 by 18, yes, right? You knew it wasn't going to be this skinny little rectangle that your rabbit's going to have to, run back and forth. So if you think about that, that makes sense. So when you think like Ms. Johnson, like who cares about this? So actually this is a pretty good application. So let's say that I was Verizon and I was trying to figure out where to put the next cell tower, right? So I already know that I have a cell tower over here and it's covering a certain amount of space. The area that it covers is actually circular in nature because it's a signal, right? And think about like if you drop a rock into the middle of a like kind of like a pool that's kind of calm, it makes that bigger and bigger ripple of water, right? So that's exactly what cell phone signals kind of work like, right? The closer you are to the cell phone tower, the stronger your signal is. Like, have you guys ever driven, I don't know, to somewhere far and your signal gets lower and lower? Or I remember when I worked in a building that was basically made of cement, like my office was all the way in the middle of that building. Because cell phone service doesn't really travel well through cement, it was really bad signal in there. Okay, so the answer for that one is a circle. Okay, the answer for that one is a circle. Very good. The next one you guys asked for, let me see if there's any more questions on that before I move on. The next one you asked for was number 9, which is the exit ticket. Good question. So whoever's asking these questions, awesome job. You should be thanking each other in the chat, because the more you know the answers are, the better it is for you in terms of getting it right. So the question for this one is, describe the features of the quadratic function f of x equals to x plus 1 quantity squared. Now, this is a very classic Miss Johnson question to ask during a quiz, right? If you remember the quiz questions that we were asking, it was something along these lines. So whenever they're asking for features, usually the features will include domain, if it's increasing, anything like that. So I'm going to go for obvious ones like domain. So I'm going to start with domain. So the domain of this function, so again, domain means what x values I can use. So literally, I look from left to right. Okay. So I look from left to right. So from the left side, it looks like I have all the values because it's going to continue all the way up. And to the right side, it's going to have all the values. So my domain for this one looks kind of funny. It's a fancy R with an extra stick. What this actually means, I think we talked about this before, means all real numbers. Now, this is every single number that you know. 2, 7, -7, -2.45, the square root of 3, even that weird pi number, all those numbers are included here. Now, Ms. Johnson, why is it called all real numbers? Actually, later on this year, you will learn that there's numbers that are not considered quote unquote real, right? Okay, so that's the domain. The range is similar, except for instead of looking at x values, we're looking at the y. And instead of looking from left to right, we're looking from bottom to top, right? So I'm looking at the bottom here. I have no function on the bottom of here, right? So where does it start? Oh, it starts right there. So because it's the y values, I'm going to write y is greater than or equal to 0. It's all of the values that are greater than or equal to 0. Ms. Johnson, is it important for me to know this? Kind of, because this is going to be a bigger player later on, like literally right now in integrated 3, this is what we're talking about. So it does become a bigger player. Other features that you know, you should also know that this is a parabola. The shape is a parabola. It's a quadratic. So I noticed in the quiz, a couple of you put like x squared instead of saying the word quadratic. I took it. Just make sure that you know you're comfortable with saying the words of these. The last thing is it has a decreasing side and an increasing side. So just like we read from left to right, we look at functions from left to right. Okay, so it has a decreasing section and an increasing section. Okay. And then the last one you asked me was number 11, which is retrieval. Retrieval number 3 and 4. Okay, so here, wait, retrieval's up, sorry. Here it is, these two problems here. Determine which function will be changing faster for large values of x on each graph. So when we say the word faster, my brain kind of goes to like thinking about like if you were going up a hill, like which hill is steeper? That's what they're asking. So if you look at f of x, it's growing, but it's not growing as fast as g of x. So in this case, g of x is the answer because his slope is greater than f of x. Okay, so I will write that down because slope of g of x is greater than f of x. Okay, And when I say greater than, I actually mean like it's steeper, right? It's steeper. Okay. This one, it looks like f of x because f of x is like, it's almost like, you know, the tortoise and the hare. At first g of x was winning and then boom, the tortoise eventually passed that. So in this case, it is f of x. And you can see just from the graph, it looks like it's going to grow faster. Okay.